In this video, we're going to talk about log transformation. So in the previous video, we talked about exponential graphs, okay? So you know that exponential graphs are curves. They either curve upwards or curve downwards based on, depending on whether the base is positive or, greater than 1 or between 0 and 1. But like curves are not easy for us to see relationships. So with log, we can turn these curves into a straight line. That's why we always say the y equals mx plus c form, which is a linear form of a graph. So always when we see y equals some exponential graphs, I said, okay, you can see what happens when we take log on both sides. When I say when we take log on both sides, please notice that when you take log, you have to apply the same base to all terms. So let's say if we're taking common log, then all the terms will be common log. And here you see if I choose to take log with respect to base A, then all the terms should be taking log base A. Okay, and I have repeated this many times already that this graph, after you take log, the vertical axis will be log y, and the horizontal axis will be x, and log b will be its slope, while log a will be the vertical axis because it's basically the form y equals c plus xn. You see this comparatively? Okay, so let's look at the first example. So every time you see a log transformation question, usually there are a few things that you should notice. First, it will tell you what was the original expression. And the other thing is it will tell you it is a linear function between which two quantities, okay? Even if this question does not give you the graph, okay, all of the information is actually within the text already. So it is okay to have no graph, okay? So you will always see this. You will always see what are the y and the x, okay, the vertical and the horizontal axis. You will have sufficient information that tells you the vertical intercept, and you'll be able to calculate the slope. Okay, so I'm going to start with the exponential expression. Okay, so you should be very familiar with this structure by now, so you can at least take log. Because this is log y, okay, common log, so I'm going to take a common log on both sides, okay? That's how you decide what base to take. And here we notice that it says the intercept on the vertical axis of the graph is -1, which means that this number, log a, is going to be -1. And we know that because this is base 10, a is 1 over 10, okay? And now the other thing that we need to find is, if we did express log y in terms of a, b, and x already, basically taking log on both sides, okay? And hence find the value of a and b. Now, how do you find b? We said that log b is actually the slope of this line here, okay? Then how do we find the slope? We have points, right? We have points. So we are going to find the slope using these 2 points, 0, -1, and 4, 2, okay? So the slope is equal to 3 over 4, which is log b. So b is 10 to the power 3 over 4. And you just put this number into the calculator, and that's going to be your b, and you will round it to 3 significant figures. All right, here's another one. Notice that the exponential, okay, in this question looks slightly different from the previous one. You can always rewind and watch it again, okay? This time, you see that the vertical and the horizontal axis shows the relation between log x base 3 and log y base 3, okay? So it's not x and log y as compared in the previous question. In the previous question, it was these, okay? Not anymore. It's log y and log x, both base 3. And it shows that the intercept of the graph, of the vertical axis of the graph is -3. That part is the same, okay? You were given a 0.2, so you can calculate the slope. But now we're going to start off with a slightly different expression. Same thing, you will take log on both sides. All right, but this time we should be taking log with respect to base 3 to 3. Okay, because the question is saying that it's a relation between log y base 3 and log x base 3. Okay, so this is replacing our normal y, and this is replacing our normal x. And we know that the vertical, the intercept on the vertical axis is this part, right? And it's -3. So we know a is 3 to the power -3, which is 1 over 27. We're done with a. And how about b? B, this time, itself is the slope, not log b, just b. B is the slope, because now the horizontal axis is this. Okay, the log goes to the x, not on the b, as compared to the previous question. Now we're going to look at the slope, find the slope using these 2 points. Okay, so it is 4 over -4, which is -1. And that is b. Basically, we're done. Okay, so in this case, b is -1. Done. Okay. If the question requires you to find y, then you will put everything back together. Okay. A to the power x, a times x to the power -1, or you can write it as 1 over 27x, like this. Okay. Here we have one last question. This time you see that the horizontal axis and vertical axis, they have different bases. So this would require base changing. Okay. Again, this question, even if there are no diagram given, you will still be able to do it because it says that it's a relation between log y base 4 and log x base 8. So you know this is going to be the vertical and this is going to be the horizontal axis. Okay? And it tells you the slope already this time, and the intercept is given. So now let's start off with here, this one. Y equals ax to the power b. So when we take log, we're going to take log. I would suggest taking log with respect to the base on the vertical axis. Okay, that would make your calculation a little bit easier. But you can also take log with respect to 8 too, but that calculation will be a little bit more clumsy. Okay, so now everything is base 4. Okay, and now we know that this part is going to be 5 over 2. Okay, because it says that the vertical axis is 5 over 2. So I know a to the power 5, 4 to the power 5 over 2, which is 2 to the power 5 is 32. Okay, so you can put this in the calculator, no fuss. And then take a look here. Notice that b is not the slope yet because our horizontal axis should be log x base 8, but not log x base 4. So what we need to do here is to pull this out and change this term to base 8. But you know base changing is not just like changing the number. You will need to adjust that, okay? So I'm going to change this, okay? This is the base changing rule. We're going to change it to base 8. And now the top part is log x base 8 already. This would be a constant. It will be 2 over 3. Again, if you don't know what it is, you can use the calculator to help you with that. Because 4 is 2 to the power, 4 is 2 the power 2 over 3 of 8. Okay, so I'm saying 8 to the power 2 over 3 is 4. Okay, but this is in the denominator. Okay, so it means 3 over 2 log 8 base 8. Okay, so now this whole thing here is replaced by 3 over 2 log x base 8. And we multiply that by b. Okay, so this whole term here is becoming 3 over 2b log 8 base 8. The slope is 3 over 2b not b. It's 3 over 2b not b. Because the slope is the coefficient of whatever this term is. Okay, this value here is log x base 8. And whatever the coefficient is, this is the slope. So now we set up an equation to solve for b. It says the slope is negative 3 over 4. Okay, so we know that b should be negative 1 over 2. So this is how you find a and b.